Kia ora. This is a neat little interactive to see the effect of Ka and Kb. So for example, we have some strong acids, HCl and nitric acid. The Ka is very large, which means that the anion, the conjugate base, has a very small Kb, so it is unlikely to react with water, as you will see in the next lesson on hydrolysis. The anions of strong acids will not react with water. Then with weak acids, the weaker the acid, the bigger the Kb. The smaller the Ka, the bigger the Kb. So the more likely that the anion of a weak acid will hydrolyze with water. Similarly for bases, for very strong bases, the equilibrium position lies very far to the right, and so there is no reverse reaction. But the weaker the base, the more likely the cation or the conjugate acid is likely to react with water and therefore have the reverse reaction. So how can we use this in reactions? If we react a strong acid with a strong base, you can see we have 100% reaction happening because the equilibrium position for HCl lies very far to the right, and the equilibrium position for sodium hydroxide lies very far to the right because of very strong Ka and Kb values, and these will not react to go back because they are very small. Similarly, if I have the HCl and say, for instance, with a weak base, I still get 100%. And you could be wondering why, because why isn't that equilibrium lying to the left? And that's because the HCl is the driving force. It wants to react completely. So the moment these try to combine to go back, the HCl pushes it forward. But if I have a weak acid with a weak base, you can see that I have hardly any reaction because the Ka for this HCN is so small, and for the nitrite, the Kb is so small, the equilibrium position lies to the left. And so as these two react to form nitrite or nitrous acid and cyanide, those will combine to go back again. So have fun exploring this, seeing the effects of the Ka and the Kb, and you will be looking at titrations in the next module, the 3063, and we'll be looking at some of the titration curves there. Kia ora.